It's 2026, and every single day there is a new way to use AI for programming. The latest one that I've been seeing is the Ralph Wiggum technique. In this video, I'm going to walk you through what it is, how to set it up with the Gemini CLI. We're going to use it to make a small Python game, and then I'm going to talk about some more advanced techniques that I'm starting to try out on a project that I'm working on. I'm Billy Jacobson. I'm a senior developer advocate at Google, and my focus is on data and AI. So we're talking about Ralph today, and we're going to take a look at this blog by Jeffrey Huntley. But first, I just want to talk about the problem that people are having with AI encoding currently. Let's see what is this problem even solving? So let's talk about that before trying to just solve any problem. I think that's always important to understand the why of what we're talking about. So there are a few ways that people are using AI to code. You might be chatting with your LLM, talking to Gemini, say, write me a function that does this and copying it into your code. Or you might be on the total bleeding edge zone in total agentic coding, maybe using something like anti-gravity, Cursor, Gemini CLI, saying, build me this thing and letting it go. Now, as projects get more complex, or if you go deeper into the chat, the AI might start failing. It might hallucinate libraries that don't exist. It might forget project requirements. It might get confused about what it's done already. And worst of all, it might get lazy and stop building stuff. It might just, throw a little placeholder there and say, to do. I think if you've been playing around with LLMs and AI agents, you will know that the more context you add, the less likely you are to get the output that you want. So here is where the Ralph Wiggum technique comes in. It's named after Ralph Wiggum, who is a Simpsons character, super optimistic, not always the brightest, but that is kind of the point of this. It's not the most optimal, it's not the brightest way to get things done, but it is a very try hard, just deterministic way to do it. To just cut to the chase, Ralph is just an infinite loop over your agents. Instead of one long chat, you ask AI to code one thing and then completely reset. Again, inefficient. It's going to use more tokens, more time, but it's going to force the context to be really refined here. I would definitely recommend taking a look at this blog post after this video, because I'm going to walk you through this in a very hello world way and then talk about more of the advanced techniques, because this is a super long blog post where he explains, he's shown some of the return on investment here. Someone got a $50,000 contract and got that done with Ralph and spent $300 on tokens. And there's a lot of graphs in this. And this one I really like, and I'll get to that in a little bit. But there's a lot of information here, and you might be seeing stuff about this, and I just want to get you started on this quickly. So let's scroll up here a little bit. And basically, it's what I said. They put a coding agent in a while loop, and it shipped 6 repos overnight. It is literally bash. It is literally just a bash loop. Ralph is a bash loop. It is a while, do, put the prompt in, and just pipe it into your agentic coding tool. And here it is. That is the beauty of Ralph. The technique is deterministically bad in an undeterministic world. So even if it's going to hit failures or a long stack trace or hallucinations, if you just feed that back into the next time it runs, it will eventually get to the correct answer. And this seems really crazy, but it makes sense. If you ask AI, hey, I'm seeing this error, and it might tell you how to fix it. If you keep asking it how to fix that error, eventually it probably will be able to fix it. One thing that really stood out to me was this, just one piece of code at a time, one feature at a time. And this is the approach I took when I was a junior engineer. My tech lead gave me this great advice of stop trying to build the whole feature at once. Build some scaffolding, then some business logic, and then some functions. And it made it easier for me to break down the problems. And it also made it a lot easier for my code reviewers, aka my tech lead, who didn't like when I was sending him large CLs. So, if we wouldn't want a human to build a whole feature at once, why is AI going to do that well? So AI can architect like a senior engineer, but we need it to implement like a junior engineer. All right, that's enough talking. I want to get into my demo. And I'm going to point out the 3 files that we're looking at. There are 5 here, just going to be on my license and README. Also, before I even show you, all of this is going to be on GitHub for you to clone, follow along, try it out yourself. So please definitely do that. So the core concept here is first we've got a specs directory. And here we're making a Python game. So specs is where we're going to define what the features are of this project. So here I want a Python game in Python 3. It's just a guess the number game, like high, low, super simple. I actually didn't even come up with this idea. I said, hey, Gemini, could you help me come up with an idea that's going to demonstrate this in a really easy way? And it picked this and I stuck with it. So the goal is you want the program to generate a random number, and then the user will try to guess it. It'll give feedback saying too high or too low, and then it'll print that you won. And then the input should just be able to handle invalid input. So this is a pretty simple application. It's going to all just be done through a bash script or running a Python. So no UI, nothing super complicated here. Then the next file that I've got is my fixed plan. So here I've got like 10 different to-dos that I wanted to do. And I also had Gemini kind of come up with these, but you can also just start with this totally blank. So we're going to create the folder structure. We're going to have a function to generate the random numbers, a function to get the input. Basically taking all of those things from the specs, or at least a bunch of the things from the specs, and having it in a to-do list. So we know, did it do it? Did it not do it? Keeping track of the progress that we're doing here. And then finally is this prompt markdown file. And this is really where the magic is happening with Ralph. So you are a senior autonomous engineer that is executing tasks with high precision and strict modularity. Because this game is pretty simple, I do emphasize a lot that I only want to do one task at once, but when you get more advanced with it, you definitely can have it do a few tasks at once, especially if they're pretty easy, like create a directory or create a function to generate a number. So first is I want it to orient and triage itself. So look through that specs directory to understand the scope of what needs to be built. And keep in mind, this is going to happen every single time. So this loop might need to run 100 times to build this. So every time it's going to go through specs and understand what we are building. Then we're going to look at the fixed plan to understand what do we need to build, what have we built, what are the set of items. And also it's going to update this fixed plan. So if there are things in the specs that are there, it will add them. Go through, kind of manage the status. Great. This is me trying to hard code a constraint so we can actually only do one at a time, because otherwise it could just build this in one go because it is so simple. But I want to help you understand the concepts here. Then phase 2, it will execute. So it'll let us know what it's building. It'll write the code, verify it, write a test or a minimal test. Great. Then once it's done, it will rewrite to the fixed plan that it completed the task, say turn complete, and then stop. Again, I'm wanting to only focus on the select task and trying to get it to not be super lazy. So it's just 3 files here is the super minimal hello world that you can do with Ralph. So now let's go into my terminal and we are going to run the command. I'm actually going to grab it from the GitHub repo. So basically what we're going to do is this while loop. I'm just echoing some stuff so we can see every time it restarts so we know it's restarted. I put the prompt into Gemini and I'm using YOLO mode. So this automatically approves any tool use. So it's going to be able to create files for us. It's going to be able to read files. It can run and write code for us. So this can be a bit dangerous if you tell it to delete everything off your computer. It might have too many permissions, but don't do that. Be smart with how you use these tools. So I'm going to click run this and we will see what it starts putting out. So it's already telling us all the things it's doing. It's listing the files in specs and source and understanding what there is. It created this project folder structure. I'm actually going to do half and half so we can see in this fixed plan, we've seen it's just going to start moving things over to completed as it's going through it. And in source, it's just throwing some code together and it's going bit by bit. Now, again, this is not going to be the most interesting thing to watch, but I want you to understand this concept of take one task. So the current task it might be doing is write a compare guess logic. That's like a super simple function. A freshman computer science student could write that function, and that's great. I want it to be really easy of what it's able to do and solve, because that just means it's going to be super easy for an agent to be able to implement that. I'm going to let this run because I don't want to sit here and monologue over our AI agent coding for us, but I will let this kind of fast forward and then we can come back and check in and see what it built. All right, all of the implementation plans have been marked as completed, which is great. And we're even getting this project victory. I think it just ran through all the tests in the last time. And it's actually going to now just keep on looping through this, checking, is there anything in the specs that needs to be changed? Is the fix plan done? And going from there. So let's just go over to this window and I can run this. I'm always nervous to run something, but I have to imagine it did a reasonable job with this. So let's start with this. Guess the number. Think of a number one between 1 and 10. Let's guess 40, 20, 35. Okay, I'm really narrowing it on it. 32. Okay, I won. So with just one prompt, I was able to build this super simple Python game. And it's honestly not so, I guess it's just a few lines of code, but we've got some great tests in here. We're testing the inputs. We're testing some of the logic, which is great. Testing the game loop. It really built a robust program here. Let me talk about a few of the more advanced ideas that are in that blog post. So I think the first one that is the most interesting is using an LLM to come up with this spec file or come up with the spec files for your entire application. This is such a simple game, but you could have 10 different spec files or 100 and have it really build out a robust application and set of features. Jeffrey, I'm on a first name basis with him, I guess. He's using this to build his own programming language. What's it called? Curse. He's making this programming language Cursed. I don't really know a ton about it, but to understand a compiler, syntax, there are so many things that go into creating a programming language. So I don't know all of them, and I don't think he does either. Not to rag on his knowledge, but I think one thing he mentions in here is he doesn't need to know how to build it. He knows that the LLM is going to be great at knowing how to build it and break down that problem. And I think that is the smart thing here. Another thing he mentioned in this blog is sub-agents. So if you've got a huge project, this is, a one file application it's made, it might take a lot of research through your application to know, does this feature exist? What is the syntax to interact in this way? What is the way that looks like? And instead of wasting context in your main loop to do this, you can send out a fleet of like 500 sub-agents to go through the code base, see what are the features, kind of give a report back to the main agent and have it go from there. And then the final thing that I think is really important, and we can actually look at this loop, is the standard library. So the specs is the features, and then the standard library is how you're building this application. So I'm just using Python here, but maybe you're building a web app and you want to use a certain framework for the front end, a certain framework for the back end. And instead of having it just try to build those things with its best practices, have your LLM define a set of rules for how you want your code to work, how you want those tests to work. Right now I'm playing around with building a podcast analyzing and co-listening app, and it's just a web app. I just started out by defining the specs. And after pushing it a little bit, it did okay. I'll pull it up in a second. But I think had I spent a little bit of time and worked on getting the standard library of saying, I'm going to need visual tests running on this web app. I'm going to need a whole set of integration tests, follow the best practices and come up with the best practices. And it's kind of this super loop. So, and then each time it makes a new change in the code, it's looking at the features, it's looking at what it needs to do, and it's looking at how it needs to do it. Let me run both of these with npm run dev. And basically, I would like the idea of I want to listen to a podcast and be able to take notes on the podcast at the same time. So I can open this up. And it actually did a really good job of being able to let me search for a podcast. So I can search for this podcast Pivot, which I really love. I could subscribe to that. But then when I went to try to listen to them, it was able to play it, but I couldn't scrub through it, or it said that this feature worked where you could click it and it would expand and that you could take notes on it. Let me test. I think the note finally worked. But then when I go to the notes page, it doesn't work. And I think building out a more complex app needs to have really robust information about how you want it to work. So like I was uploading these screenshots and being like, take a look at this screenshot because it is not what you're saying it looks like. All of these tools, all of these ideas are so new. And even if they don't work perfectly, I think 2026 is about taking the tools that were built in 2025, pushing them to their limits in new and interesting ways. I've got this Hello World up for Ralph in my GitHub, and I will link it below. So clone it, run it, and see if you can build something more complex and let me know how it goes. Thanks so much for tuning in. If you like this video, give it a like, subscribe, and I hope to see you soon. Bye.